Right. Today we are going to start with this 2020 June S1 paper. Right. You start with the first question. It comes with discrete random variables. The discrete random variable x is taken from -1, 2, 3, 4, and 7 only. Given that this is a probability distribution function, find the value for ex. To do this question, what you need to do is initially we need to make the probability distribution table. X values are -1, 2, 3, 4, and 7. Then we need to find the respective probabilities. If x is -1, you have to replace -1 over here. 8 minus -1 is 8 plus 1 is 9. This is turned up to 9 over k. Then if I put 2 here, 8 minus 2 is 6. 6 over k. 3 then what? 8 minus 3 is 5. 5 over k. If I put 4, 4 over k. If I put 7, 1 over k. Then what you can get here is, then we need to find ex. Ex is, right. Then initially to find ex, we need to find the value for k. How do you find the value for k? If you add them together, simply you can get the, it's equals to 1, because you know that's a probability distribution function. If you add them together, that is equals to 1. So I can say 9 plus 6 is 15, 20, 24, 25. 25 over k is 1, therefore k is equal to 25. Now you know that this value, this is exactly all the figures are 25 itself. Therefore we can find the ex. How to find the ex? X into pxx. X is -1 into 9 over 25 plus 2 into 6 over 25 plus 3 into 5 over 25 plus 4 into 4 over 25 plus 1 into 1 over 20. Sorry, 7 into 1 over 25. This one to this, like that. If you simplify this, you get the answer for ex. So we will work out and see. Yeah. 41 over 25 would be the final answer for this. That's a way of getting the first answer. In a school canteen, the student can choose from a main course meat, fish, or vegetarian. They can be chosen the drink with either water or juice. Right. The partially completed Venn diagram, the PQ, are the probabilities, show that the probabilities of the choice of the random selected student is, these are the facts they have given. So we need to fill up these facts. So initially I'll start from the first part of it. We know that if you add them together, that is equivalent to 1. So if it is turned up 0.75, so this should be 0.25. Then this one should be 1 minus p. And this is 1 minus q. And this is 0.6. We know that individual additions should be 1, because that is a 1 complete event we are going to see. Complete the diagram, give you answer in terms of p and q in p and q were appropriate, right? Okay, so we can get these answers like that. Find an expression in terms of p and q, the probability that randomly selected student chooses a water to drink. That the water to drink means these columns. Turn up to then you can get these figures. You can say this one, this probability should be 0.4 into p. This is part B, plus the next one is this bit, 0.35 into q. Next one. The last one is 0.25 into 0.4. So this answer becomes 0.4p plus 0.35q plus 0.25 into 0.4 is 0.1. That's the first expression for that. Right? Then they mentioned that this condition, this one means the event choosing vegetarian main course and choosing water to drink are independent. Find a linear equation in terms of p and q. Choosing vegetarian main course and water to drink, those are independent. That means, Pute, if you work out this, the probability of vegetarian, veg, into probability of water should be similar to probability of veg intersection water. That's a condition we have to work out with the independency, right? Probability of being veg. is simply 0.25. In probability of water, we already found this answer, that is 0.4p plus 0.35q plus 0.1 is equal to vegetarian intersection water. Vegetarian intersection water means it should be a vegetarian and as well as water. 0.25 into 0.4. Now you can see you can cancel the 0.25 with the value over here. So with that you get the answer 0.4p plus 0.35q plus 0.1 is equals to 0.4. So from here you can get 0.4p plus 0.35q minus 0.3 is 0. This is a one expression where they want to get it right. We go ahead a little bit further. The student who chooses a juice to drink is selected at random. Find the probability that they choose a fish for their main course is 30/7. Find the value for P and find the value for Q, right? Look at this is condition. The student who chooses the juice to drink. That means, when you talk about D, they have selected juice, J. Choose to drink is reference. Find the probability that the probability that choose fish for their main course, fish, is given as 7/30. Right. Then we can form another equation. But if this is a conditional probability, you can say probability of fish intersection J divided by probability of J is equals to 7/30. Right. Then you can say fish intersection J. Fish intersection J means 0.35 into 1 minus Q. Fish and juice. Divided by probability of juice is, look at it, there's a one trick we can understand from this question is juice means this one, or this one. But you can understand that if you want, you can write like these, and these. But rather than that, we already gotten the probability for this one. Then if you get 1 minus of this part, 1 minus of the probability of watering, you can get the probability of juice. So other than that, if you feel like confusing, you can use this branch into this, plus this branch into this, or this branch into this, even you can get it, not a problem at all. But I will use this expression that is turned up to 0.4p plus 0.35q plus 0.1 is equals to 7/30. Right. Then I'm going to find another expression for this. Then I will initially cross multiply these two. It's turn up to then. That is 30 times of 0.35 into 1 minus q is equals to 7 times of, if you do this, 1 minus 0.1 is 0.9, 9 minus 0.4p plus 0.35q. From here you get the answer 30 into 0.35. That is 10.5. 10.5 minus 10.5q is equals to 6.3 minus 2.8p. This should be, this one also minus, but so this is minus 2.45q. 45q. So if you bring all the terms to one side, I can bring the 6.23 to this side. With that, 10.5 minus 6.3, that is 4.2, is equals to, if you bring this this much, minus 2.8p that is 8.05q. 8.05q. This is another equation. So I have another equation from here. Okay, you can say this is 0.4p plus 0.35q is equals to 0.3. This is my first equation. By solving these two, I can get the what do you call that? Solutions for p and q. That's the approach what they want. 0.4, 0.35, and 0.3. This is minus 2.8, 8.05, and 4.8. This answer, one answer is, yeah. Then you get the answer. P is equals to 0.225 and Q equals to 0.6. Initially, we can come up to this point. Now, okay, now what you can understand is here we already found the value for P value and Q value. Therefore, I'm going to replace these answers over here. Sorry, not the filling that. So it's done up to 0.6. Here the value we already want. The value for Q is 0.6. So this should be 0.4. And this is 0.225. So the other one is 1 minus 0.225 is 0.675. 0.775, sorry. So this answer is 0.775. Okay. Then what you need to understand is here, they mention the canteen manager claims that the students who choose the water to drink are most likely to have a fish as a main course. State showing or working clearly whether or not the manager's claim is correct. Let's work out and see. So what you need to understand is we know that the specific customer bought the students who chooses a water to drink is most, yeah, chooses a water to drink. We already know it. They have chosen water to drink. They mentioned that they may have a more tendency of buying a fish as a meal, right? We will work out this condition and see whether what is the probability of, if you know the probability of which buying a water and what is the tendency of having buying a fish as a meal. You can say fish intersection W divided by probability of W, right? Okay. Then over here, fish intersection W. So I'll start from this question. Fish intersection W is 0.35 into 0.6 divided by probability of choosing water, right? So you can say this is 0.4 into 0.225 plus 0.35 into 0.6 plus 0.25 into 0.4. And we will see whether what is this conditional probability over here. When you're working out it, you'll understand. There's a very interesting fact you got it from this answer for this. 0.225 plus 0.35 into 0.06 plus 0.25 into 0.4. That answer is 0.525. Now you can see the probability after knowing that they are buying water to drink, the probability of choosing fish as their main meal is more than half of it. That means it has a more tendency. Half means 50-50. If it comes to 0.5, it's 50-50. But if you come up to 0.525 means it's more tend to buy the fish as a main course. So you can say, therefore, the claim is true. The claim is true as the probability is more than half. That's what we need to understand with this question, right? Okay. The distance achieved in long jump competition by students at school is normal distributed with mean 3.8 and standard deviation of 9. So you can say this distribution gain, normal distribution, the distance travel is mean is 3.8 and the standard deviation of 0.9. Right. The student who achieved the distance greater than 4.3 meters will receive a medal. Find the proportion of the students who receive a medal is, you can say, probability of the distance you travel is more than 4.3. So you can use the standardizing. When you make the standardizing, the variable set up Z, 4.3 minus 3.8 divided by 0.9. So this is turned up to probability of Z is greater than 4.3 minus 3.8 divided by 0.9. So that value is turned up to 0.56. That means if you draw it in a what you call normal distribution table, it's 0.56 a value over here. We are referring to this answer. Then if you read 0.56 from this table, 6 from the table. Yeah, if you read the value of 0.56, they give you the lesser region. But what I need is the greater region. Therefore, I can find this value by this way. 1 minus probability of Z is less than 0.56. That is 1 minus, if you read it, 7123. 0.7123. 1 minus 0.7123. So that probability becomes 0.2877. 0.2877. That would be the answer for this question. Right. Then let's go to the next part of the question. The school wishes to give a certificate the achievement of the medal to be 80% of the students who achieve a distance of at least d meters. That means at least d means the distance they jump should be greater than a certain value of d. It should be 80%. 80% means as a probability 0.8. Right. Find the value for d. Right, let's work out and see today. Yes. Right. Then we will work out and see. Initially, we have to work out the standard normalizing. Z is greater than d minus mean value is 3.8 divided by 0.9 is greater than 0.8. Now, what you can understand is here the greater region, we cannot read it from the table. Obviously, we need to work out the lesser region. Or other than, yeah, that is probability of Z is less than d minus 3.8 divided by 0.9 is equals to, if the greater region is 0.8, obviously the lesser region should be 0.21 minus of this answer. But the problem is, if you come up to this table, because we need to convert into this format, because we cannot read the greater region from this table. But when you turn to the lesser region, again, 0.2 is not available. The minimum probability available here is 0.5. Then to correct it, what we need to do is, we can do like this. We can say probability of D is less than 3.8. Sorry. Just do a small correction. I will take the side of this page. Probability of Z is less than D minus 3.8 divided by 0.9. It's not there. For that case, again, we will take 1.2 and get the value for 0.8 and read it from the table, the 0.8 probability. You can go to the most closer figure if the 0.8 is not there. Or you can use the other table as well, but getting from here is kind of easier. 0.84. Then you can write, this is the point you write, 0.84 and put a minus in front of this. That's the logic we use. For the lesser region, if the value is too small, we have to get 1 minus and put a minus in front of it. If you simplify this, you get the answer D as minus 0.84 into 0.9 plus 3.8. That answer is 3.044. 3.04. Yeah. The 3.04 meters. You can get like that. Okay. That's the answer what you need to get. Then, this is the important question in this question. Means like this is important part of this question, right? Of those who receive a medal. Those who receive a medal, medal means we know that this value. Probability of distance travel is, we know that it's more than 3.04. It's given. Those who receive the medal, who jump the furthest, one third who jump the furthest will be receive a gold medal. That means you have to take a jump of more than a certain value of K. This proportion is 1/3. Find the shortest distance of G meters that would be achieved to give the movement. That means you have to find what is the value for G. They got to get as this one as G for the gold medal, right? That means out of the people who get this one, it's already given, they receive a medal, then what is the probability to be jump to get a gold medal? They have given this proportion over here is 1/3. And if you write it, probability of X is greater than G, intersection X is greater than 3.04 divided by probability of X is greater than 3.04 is 1/3. Now there's a logic. Then we know that there obviously 3.04. And this one is more than G. Obviously, you have to get a more jump than this one to get a gold medal. Therefore, this should be G. Then what is the common region for this? Obviously, this turn up to probability of X is greater than G. Divided by, we know that probability of X is greater than 3.04 as 80%. We already got this answer. That is 0.8 is equals to 1/3. Then we can work out, if you simplify this, you get the answer. Probability of X is greater than G is equals to 0.8 divided by 3. 0.8 divided by 3. With that, you get the answer 0.2666 or 2667. Right. Then initially, what I need to find is I want to make them into initially the standard normal. Z is greater than G minus 3.8 divided by 0.9 is equals to 0.26667. Sorry. Then we know that greater region, you can't read it from the table. Therefore, you can write Z is lesser region should be D minus 3.8 divided by 0.9 is equals to 1 minus 0.2667. That is literally similar to 1 minus 0.2667, 7333, 0.7333. Then if you read the 0.7333 from the table, 7333. The closest figure is 0.62. 0.62. Just 1 second. Here 2.6 is 7333. Yes. Yes, but another question, there's a small issue with that question. I didn't read the question properly. That's a point. Those who receive a medal, to receive a medal, this is not the requirement for that. To receive a medal, this one, the distance achieved by the long distance distance. This bit, the student distance more than 4.3 receive a medal. Therefore, this is the condition. So I made a mistake here. It's not 3.04. That is the point. That is why we couldn't get the proper answer for this. This should be this. So this should be 4.3. 4.3. This is 4.3. Anyway, the top is not there. 4.3 and probability of X is greater than 4.3. Right now, that's a point with it. Sorry, I made actually it's my mistake. I didn't do it. I didn't read the question properly. Means like you have to be very carefully read this question when you're working out it. Yeah, let's go ahead with this. Then probability of can make it as X is greater than G. More than 4.3 value is put there. We already found it here. We already got that answer. More than 4.3, we got the probability as 0.2877. 0.2877 equals to 1/3. Then you can say X is greater than G is 0.2877 divided by 3. That turn up to 0.0959. 0.0959. Then we have to make them into standard normal. Z is greater than G minus 3.8 divided by 0.9 is equals to 0.0959. Then do it here. That is, you know that greater regions you can't read it. With that you can write. Therefore, the lesser region should be G minus 3.8 divided by 0.9 is 1 minus of this answer. It's turn up to 9041. 041. With this you can write G minus 3.8 divided by 0.9 would be 9041, you can read it from the normal distribution table. 9041. 9041. Its closest figure is 1.31. Can make them into 1.31. Then with that you can get the answer G would be so the G should be 1.31 into 0.9 plus 3.8. Then you get the answer 4.97 roughly 4.97 meters would be the rough answer for that question, right? Then the journalist from a local newspaper interviews a randomly selected group of 3 medal winners. 3 medal winners. Find the exact probability that at least one of a gold medal winner in the group. Right. So when you get the this one, so out of these gold medals, all of them are gold medal winners, but you know that only 1/3 of the gold, sorry, 1/3 of the what do you call that, medal winners will get a gold medal, right? Okay, so rest of them cannot be a gold winner, right? The journalist from a local newspaper interviewed the randomly selected group of 3 medal winners. Out of that, only 1/3 having a what do you call that, the probability of having a gold medal winner would be only 1/3 out of that batch. Find the exact probability that there would be at least one gold winner. So you can see the first one out of that medal winners, only 1/3 may be a gold winner. 1/3, then other one is 2/3. The second one, even you can say it's a gold winner, not gold. 1/3 and 2/3. Turn up to G and G dash. It's 1/3 and 2/3. G and G dash. 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 1/3 and 2/3. Now you can see out of this branch, all other branch gets at least one gold win. Therefore, you can say 1 minus 2/3 into 2/3 into 2/3 would be the probability. Whatever the other branch, we get at least one gold winner. So it's pretty simple. You can get the answer as 19/27. That's the final answer for this question. Okay. Okay. Here, when you come up with this question, a group of students took some test. The teacher is analyzing the average mark of each student. Each mark obtained the different average marks. For the average marks, the lower quartile is 24, the median is 30, and the interquartile range is 10. Therefore, with this information, we can find the what do you call that, Q3. We can say IQR is equals to Q3 minus Q1. So the IQR they have given it's 10. Q3 minus Q1 they have given as 24. Therefore, Q3 is 34. That's what we need to understand with this question, right? The 3 lowest average marks, 8, 10, 15.5 are the 3 highest average marks. So lowest ones and the highest ones are 45, 52.5 and 56. And they have given the outlier figures are more than 1.5 from IQR below the lower quartile and more than just usual what you call lower boundary and upper boundary range with factor of 1.5. Determinant in outliers in this data. So you can see initially lower boundary. It's Q3 plus, sorry, Q1 minus 1.5 times of Q3 minus Q1 or IQR. So the Q1 is, we already got this answer as 24 minus 1.5 of IQR is 10. It's turned up to 24 minus 15 is 9. So the lower boundary gotten here as 9 and the upper boundary is Q3 plus 1.5 times of Q3 minus Q1. That is Q3 is 34 plus 1.5 times of 10. It's turn up to 34 plus 15 is 49. Yeah, that is 49. Then we need to understand that you can go up to 9. That means for the lower side information, 8 is an outlier. Outliers are 8 is one value. For the upper range, 49. 49 means 52.5 and 56 are outliers. So these are the outliers for this question, right? On the grid below, draw the box plot of this data, right? Okay, we'll try to work out with this. Now, initially we know that lower boundary is 24. I will mark it here. 24. And median is 30. It's here. And the upper boundary is 34. Then lower boundary is, this is the point you to understand. Then our 8 is an outlier. So I just mark 8 is an outlier. We can mark it as a cross 8. And for the upper region, 52.5 is an outlier. Here, and 56 is an outlier. Then the what do you call that? Lower boundary. Up to 9 is lower boundary. We know that for the lower side, the ranges are 8, 10, and 15.5. This is the point you have to understand that up to 9 you can go ahead, but 8 is an outlier. Then the next recent lowest value is 10. Therefore, 10 become the lower boundary. That's the logic we need to understand. For the greater region, the maximum value is 49. So you can understand that these two figures are higher than that outliers, and the 45 is the next highest value. Therefore, 45 become the upper region, upper boundary. So that is the way of drawing the box plot. That is a way of handling this question. Use the quartile to describe the skewness of this data. So you can understand that here, this part is narrower. That means the gap is just like this. This part is narrower means gap is like this, which turn up to a positive skew. So you can say Q3 minus Q2 is smaller than Q2 minus Q1. Therefore, it's positive skewed. That's the answer what they want to answer this question. Right? Okay. The two more students also took the test. The average marks, which were both less than 45 and added to the data and to the box plot. It's more than less than 45 added to the box plot of the redraw, right? The median and the upper quartiles are the same, but the lower quartile is now 26. Redraw the box plot on the grid below, right? Okay, we'll try to analyze this question. Okay, right. When you come up with this question, now for this, the fact we have given is the new median. The median is does not changes. Yeah, median and upper quartile are the same. The median is according to this information, it's 30. Yeah, median is 30. And upper quartile does not changes Q3. Q3 is 34. But what they mention is but the lower quartile is now 26. Now Q3 is 20. Q1 is 26. Now we can find IQR. IQR become 34 minus 26. 34 minus 26 is turn up to 34 minus 26 is 8. Now IQR become 8. So the lower boundary is turn up to Q1 26 minus 1.5 times of 8. It's turn up to 26 minus 1.5 times of 8 is 40. Now it's turn up to 14, right? Then according to this information, then lower upper boundary. Upper boundary is 34 plus 1.5 into 8. It's turn up to 34 plus 1.5 into 8. It's turn up to 46. 46. Now let's work out with these figures. we can mark the Q1, sorry, yeah, the Q1 is 26, so you can mark 26 here. We'll start from that 26, and a lower bound, sorry, Q median is 30, and the upper boundary is 34. With this, then the lower boundary available here is 14. Now check whether the values which is less than the 14 is work out the less than 14 figures are 8, 10. 8 and both are lesser than that. Therefore, we can mark these two as an outlier, and the next largest value is 15.5, whereas this should be the upper bound, lower bound, sorry, like this, and it should be like this. Then the highest value is 46. 46, therefore 52.5 and 56 are outliers. 52.5 and 56 are outliers, and the upper value should be 45. Doesn't make a sense with that, because anyway it not should make any effect on the final answer. So that is the answer for this question. Then you a box plot, right? Give a range for value within this in which a student average marks must lie. Give a range of values within which this bit. So which of these students average marks must lie? So you can see this is a some kind of like which of these students average marks must lie. So over here, you know that average marks is because it seems to be almost close to a symmetrical shape with it. Therefore, the average marks can be fall into one of these figures. So you can mark it can be falls between 26 to 30. Since it's kind of symmetrical when you look into this shape. So in between 26 to 30, we can observe the average marks will fall in this question. That's a factor to understand with this. A large company rents shops in different parts of the country. The random sample of 10 shops. So over here, you should understand that N is 10. This is N, right? It's taken with the floor area in 10 square meters and the annual rent Y in thousands of dollars. You have to keep this scale a little bit of concern because we need to get the final answer. You might need this what you call transformation before you get the final answers. But data was summarized below as shown the statistics summation of x squared, y and y squared is given. And the regression line has an equation of this. So keep this literally. Use the regression line to estimate the annual rent in dollars for the shop with a floor area of 800. If the floor area is 800, it's given in 10. Over here, x is given in scale of 10 square meters per day. So therefore, 800 square meters means in the units of 8, x should be 8 because it's the x is given in scale of 10 square meters per day. Then you can substitute y is equals to 6.066 plus 0.136 x. X instead of x, you can substitute 80. With that, you get the answer x is equals to, sorry, y is equals to 16.946. Whereas this value is given in thousands. Therefore, what is the exact amount? Exact amount should be 16,946 pounds. That would be the final answer with that, right? Okay, then let's come up with this question, part B. Part B is SYY. To find SYY, you can easily get it because the formula is summation of y squared minus summation of y whole thing squared divided by n. Summation of y squared is 3434 minus summation of y is 183 squared divided by 10. Now let's get this answer. With that, summation of y become 85.1. Then SXX, you can find it by summation of x squared minus summation of x whole thing squared divided by n. Summation of x squared is 84,818 minus 900 squared divided by 10. With this, you get the answer as 3,818. If you place this into the calculator, you can obtain this answer with that. Okay, let's go ahead with this. Then the product moment correlation coefficient, right? Now there is a problem we come across. Gamma is equals to Sxy divided by square root of Sxx into Syy. Now to find Sxy, summation of xy is not given over here. But there is a clue over here is we know that from this equation, the gradient B is equals to Sxy divided by Sxx. And whereas B is 0.136 equals to xy divided by Sxx, we already found it, 3,880. With this, you can get the answer. Summation of xy is 0.136 into 3,880. That is 519.284. Sorry, 248. So with that, you can get this answer. 0.248 divided by the square root of 818 into 85.1. 0.9101. 0.9109. It's the final answer for this question. That's a simple way of getting the answer for this, right? And Levenshop is added to the sample. The flow area is 900. 900 means that value is 90. And the annual rent is $15,000. That means this value is 15. Okay. Use the formula Sxy equals to summation x minus x bar into y minus y bar to show that the value of xy of Levenshop will be same as the value in the original 10 shops. Sorry. So now you can see if you get the new value, another 90 is added with it. Summation of x become, initially it's 900 plus another 990, it's turned up to 990. Therefore, x bar would be 990. Now there are 11 elements with it. So it's turned up to, still it's 90. Then if you get Sxy is equal to summation of x minus x bar times of y minus y bar. Now you can see for this expression, another added element. So with the existing x minus x bar figures, x minus x bar plus the new value is 90 minus 90 with it. Because the added value is 90 and the mean value was 90. So therefore, it doesn't make a difference over here. So this value should be how much per day? This value should be 90 minus 90 is turned up to 0. Therefore, if you multiply 0 with this, it doesn't make an impact on the new added information. Therefore, Sxy will be remain as it is. Remain as it is. Because the new added value does not make any change over here. Right? So there, from there, you can say this value is okay. Then, right. So that is the same thing. Okay. Then we can say find the new equation of the regression line y on x in the Levenshop. So we can say Sxx. Sxx is how much? You can say summation of x squared minus summation of x all things squared divided by n. The initial summation of x squared is 84,818 plus another x squared should be added. New x is 90 squared minus here summation x at the beginning is 900 and 900. Another 90 is added, square divided by 11. If you work out over here, let me see what would be the value for Sxx. Would be 84,818 plus 90 squared minus 990 squared divided by 11. That value also put it 3,880. Now, what we can understand is the new gradient for this graph. You can understand that Sxy and Sxx both does not changes. Therefore, for the new line, the gradient should be remain as it is. The gradient B should be Sxy over Sxx. Both does not changes. Therefore, it would be the same thing as before. So it's turned up to plus 0.136. Then we need to get A. A equals to y bar minus bx bar. Total y bar. The old y is 183. Another 15 is added from here. Divided by 11. Minus b is 136.136 x bar. X bar is same thing as before. 990 divided by 11. So with this, you get the new value for 8. 183 plus 15 divided by 11 minus 0.136 into 90. Then the new value become 5.76. So you can write the new regression equation is 5.76 plus 0.136x. It's a new value for that. That's a way of getting the answer for this question. Right. Then the company is considering renting a large shop with the area of 3,000 square meters. Comment on the suitability of the use in the new regression format. If it is 3,000, yeah, that value should be turned up to 300. So now you can see all of these values are not in this much of a range. So you can say this 300 is 3,300 is an extrapolation. Therefore, this might not be suitable. You can hear all the values of this ones are just around average of 90. Average of 90 means 900, but 3,000 will be extremely high compared to the rest of the information in the set. Therefore, it not might be suitable for this. That's answer we need to write for this question. Okay. Right. Now, when you come up to this question over here, we work out and see. The random variable A represents the scope when the spinner is spun. The probability distribution A, the given table is show that EA equals to 3.5. This is pretty simple. You can get the value for EA by 1 into 0.4 plus 4 into 0.2 plus 5 into 0.25 plus 7 into 0.15. If you do this, you get the answer 3.5. Then part B, we find the variance of A. To find the variance of initially, we find EX squared. How to find EX squared? 1 squared into 0.4 plus 4 squared into 0.2 plus 5 squared into 0.25 plus 7 squared into 0.15. That is this one squared into this one squared into this one squared into this, and this one squared into this. With this, you get the answer EX squared as you get the answer 17.2. With this, you can cite variance of X, a variance of A actually, EX squared minus EX all things squared. So it's turned up to 17.2 minus 3.5 squared. With that, you get the answer as 4.95. That's a fact to understand, right? A random variable B represents the score on the four-sided dice. The probability distribution B for it's given in the form of 1, 3, 4, and K of this one. Write down the name of the distribution B. So you can see it's a discrete uniform distribution because all the probabilities are similar. You can say it's discrete uniform distribution, right? Okay. The next one, given that EB equals to EA, state giving reason the value of K. So this is, you can see this 1 mark question means nothing to do much work with this. Here we know this 3.5. It's equals to how to find the mean for this today. You can, if it is a discrete uniform distribution, mean you can get by addition of these two divided by 2. Get the answer, K become 6. Is the answer for this today. That's a simple way of getting the answer. Okay. The random variable X has a uniform distribution, normal distribution of mu and sigma squared. The Sam and Tim are playing the game with the spinner and the die. They each spin the spinner once and obtain the value of A. Okay. Each roll the dice once, obtain the value for B. Right. The value of A is taken as their value mu, and the value of B is taken if the value of sigma. If they're taken their value of sigma, the person with the larger value of probability of X is greater than 3.5 is the winner. Given that Sam obtained the value for A is 4 and B is 3, and the Tom obtained B equals to 4 and fine. Giving reason, the probability of Tim wins. Right. Okay. Let's try to understand this question. Right. Yeah. If I repeat this question, right, look at this. The each spinner wants to obtain the value for A, and for this case, if this is the what we call A is the reading by the spinner and the B is the reading by B, right? Then for Sam, A is 4 and B is 3, and probably to win the game, he should gain more than X should be more than 3.5. Then for Sam, if you calculate the probability of X is greater than 3.5 with this ordinary simplification, you get the probability of Z is greater than -1/6. That should be 0.4364. Then if team wants to win the game, definitely the probability of winning what the team should be greater than this answer. For team, we know the B value is 4, the standard deviation value is 4, but we don't know the value for A. If you work out this with the simplification of this A become more than 4.16. This is a simplification which I gain for A. A should be greater than 4.16. That means for A more than 1.46 means it should be either 5 or 7. So out of these two, you can get the probability of 0.4. That's a way of doing this question. Right? The next question is, find the largest value for probability of X is 3.5 achievable in this game. Now look at this. Like, let's see this EX value. So I'll just make a small diagram for you. We pick A as a mean value and B as the standard deviation value. Now look at this. If this mean is these ones, if the mean is 1, if the mean is 1, the probability of getting 3.5, it's somewhere over here. You get the probability of this region. If the mean is 4, if the mean is 4, the probability of getting 3.5 more than 3.5 is this area. If the mean is 7, the probability of getting 3.5 is this bit. Therefore, to get the largest value for probability of X is greater than 3.5 must be at the largest mu value. You can see that when the mu become larger and larger, the probability of getting more than 3.5 become more and more. That means you have to get A value as the largest value for that. Then look at this. If I will get the same mu value, I'll get the largest value as the mu is 7 with the what do you call that, broader and a narrower standard deviation value. I'm doing the same thing. This is with a broader standard deviation. This is with the wider, sorry, this is with the wider standard deviation. This is with the broader standard deviation. Right. That means, sorry, if you just draw it nicely, yeah, like this, just draw it in a one diagram, can it be kind of like easier to understand. I will get two distributions where mean is 7. Mean is 7. One is with the what do you call wider standard deviation. If it is a wider standard deviation, it's just like this. If it's a broader standard deviation means the more info, sorry, if it is a, this is for the wider standard deviation, with the broader standard deviation, broader sigma. If the sigma is a small value, if the sigma is a small value, you can see the distribution becomes somewhere like this. This is sigma is low and this is sigma is high. Therefore, if you want to get the larger probability, definitely what should be the condition? A should be maximum and B should be minimum. That's a condition where we need to understand for this question. Those are a little bit of practical aspects of this mean values, right? Therefore, if you want to get the largest value, we need to operate with the highest value for mu. Therefore, X must be with a normal distribution of mean 7 and standard deviation should be the lowest value obvious 1 squared. Then we can find probability of X is greater than 3.5 with this. So we can write this is Z is greater than 3.5 minus 7 divided by 1. Probability of Z is greater than minus 3.5. Its probability of Z is less than 3.5. So with this answer, you can obtain the answer as if you use a table for 0.35, work out with this 3.5, it should be somewhere here. A little bit of down, sorry. 3.5 is somewhere here, 9998. So the probability should be 0.999. 0.9998 is the answer for that question. That is the approach for this question. It's approach for, sorry, by part E. Okay, right. Then find the probability of achieving this value. To achieve this value, what is the requirement? A should be 7 and B should be 1. That's a condition where I should satisfy. So therefore, the probability of being A is 7 is 0.15 and B is 1 is 0.25. So answer should be 0.0375. To get the highest probability for that, this should be satisfy and this should be the probability for that. That's the way of getting this answer. I think you might not understood how do you get the answer for question number E. Seems to be. Let me explain it again because those that is for the people who cannot understand it. What they do is they spin. They spin the spinner and as well as they take the dice. So when you are working out with this, what they do is they will consider. They mention here a question like this. The random probability of X is normal distribution of mu and sigma. So that is what the Sam and Tim are playing the same, playing the game with spinner and the dice. They each they spin the spinner once and obtain the value for A on each roll and die once to obtain the value for B. The variable A is taken for the value for mu and the variable of B is taken for the value of sigma. The person with the larger value for probability of X is 3.5 is the winner, right? Okay. Then what they do is now the Sam was rolling this one today. As a result, Sam get discount. Sam get 4 as the count at A. Therefore, for Sam, you get a normal distribution of mean 4 and the other one is, I'll make it a little bit of small, then it will be kind of clear for you. And B is 3. That means you get a mean value, so standard deviation as 3. Now this is his distribution. Now let's see with this information, what is the probability of winning him? To win the game, he should get a score of more than 3.5. That means using this distribution, we count the probability of winning this one from this table. You can say probability of X is greater than 3.5. Now with this information, now what they do is after getting the what you call count you obtain by the spinner and the dice, we count this probability. If this probability is more than 3.5, we get the we say that person is winning the game, right? Okay. Now let's see what is the probability of Sam to win the game. Initially, what you need to do is you have to make them into standard normal. Z is greater than, with this count, 3.5 minus 4 divided by 3. So this is probability of Z is greater than minus 1 over 6. That's a count you need to understand, right? Okay. So we will try to find out the probability of Sam to win the game. You just do it. You can say this is, if you make them into the standard way, is 1 over 6. That is, Z is less than 1 over 6. So you can't get it. That is less than 1 over 6. You can find it from the table. Is probability of, so you can work out like this. Probability of Z is less than 1 over 6 means 1 over 6 is 0.166. 0.166. Then if you work out with this, you get the probability of roughly 5675. 0.5675. Right. Then what they do is, now if you do it for team, the second person, X, he is getting a distribution of X is having a normal distribution of mean value he don't know. Sorry. Yeah, he don't know the mean value, new mean. And you know the standard deviation is 4. Then if team wants to win, what is the condition? He should score more than 3.5. He should score more than 3.5. So if you work out with this, probability of Z is greater than 3.5 minus A divided by 4. Then what is the condition? If he wants to win this game, he should get a more probability than this. That means probability of Z is greater than 3.5 minus A divided by 4 should be greater than 0.5675. That means we know this probability as Z is greater than minus 1 over 6. That means simply without doing much simplification, this should be greater than 1 over 6, because we already found that the value relevant for this one is minus 1 over 6. Then we can write 3.5 minus A divided by 4 should be greater than minus 1 over 6. So if you simplify this across, 3.5 minus A into 6 should be greater than minus 1 into 4. Turn up to 3.5. 3.5, we already did this calculation, into 6 is 21. 21 minus 6A should be greater than minus 4. Therefore, if you multiply with the negative mark for the both sides, with this, then you can make them into positive with that. We just do this here. Yeah, turn up to minus 4 minus 6A should be greater than minus 25. Therefore, A should be greater than, turn up to how much? 25 divided by 6. 25 divided by 6 should be 4.16. 16. That would be the answer where we need to work out with this question. Probably should be greater than this. That is, yeah, that's it. Right. Then what you can understand is, but then now see whether what is the probability of getting for A as 4.16. That means he should get 507. That means A should be 507. What is the probability? 507 probability is 0.25 plus 0.15. The probability should be 0.4. That is a way of obtaining the answer for this question. So simply you can obtain the answer like as a probability as 0.4. So hope you can understand, but this question is a little bit of confusing and it has more complex simplifications are there when you're doing this question.